Hey everyone, welcome you all. So in this video we are going to see ideal op-amp characteristics. So what are the characteristics which are expected? So the ideal characteristics are the one which are superior. So somewhat we will be expecting these characters. So in general, we are representing the op-amp with only four, say 5 pins: V plus, V minus, Vs plus, Vs minus, and V out. But we are neglecting the internal resistance and the output internal resistance, that is R out, and the source voltage GV in, that is the voltage which is produced inside the op-amp. So these characteristics or terms we will be neglecting in our general discussions. So there will be an internal resistance, because if you want to connect these two terminals, then we will be using some material, conducting material like copper on the PCB. So that definitely has some internal resistance. So that's why we are having Rin as the internal resistance, and plus or plus minus V in will be the voltage drop across that internal resistance. So similarly at the output also we'll be having output resistance and the voltage source at the output. Okay, so we'll see now what are the characteristics. So first one is the infinite open loop gain. So open loop gain means open loop basically terms to the no output is fed back to the input again. So if the output is, some part of output is taken and it is given to the input again, then it becomes closed loop. So in this case there will be no closed loop, means there is no feedback input. So the output is not fed back as the input for this op-amp. So open loop gain is always output by input. So voltage which is output divided by the input voltage, that will give the gain. So we want gain as much as possible. So as the name suggests, it is an operational amplifier. So if you give 1 volt as the input, then you expect 100 volt as the output. So we just want to amplify our signal. Okay, so gain is what? So if the gain is 10, so suppose gain is equal to 10, then if you give 1 volt as the input, then output voltage, that is V out, will be gain into the input voltage, that is V in. So gain is 10 and input voltage we have given 1 volt, so it will be multiplied with 1 and the output will be 10 volt. So what it indicates, as the gain of the op amp increases, the output voltage increases. So we want the gain as much as high as possible. So the highest gain which can be possible is infinite gain, that means it will be in terms of million trillions. Okay, so the first characteristic is infinite open loop gain. Then coming to the second characteristic, that is infinite input impedance, that is Rin, and so zero input current. So any source we want, so op amp is operating with a current or voltage of 1 milliampere, suppose we assume. So if the resistance of the input terminal, that is this terminal, increases, then the current which is entering this op amp, suppose say this is op amp, then it will be very less. So what basically we want to save the power, so that's why input resistance, impedance means resistance. So if it is in AC, then we will be calling it as impedance. So input resistance of any device should be very high, so that it should take only low power, and the power will be saved. Okay, so that's why infinite input impedance means very high input impedance, so that's why it will consume only less power. Okay, and zero input current, so current drawn should be zero. So this is the second. And coming to the third point, zero input offset voltage. So before knowing zero input offset voltage, first we should try to know what is meant by offset voltage. So we know the basic property of the op amp. It will try to keep the both the ends, that is V plus and V minus, at a same voltage. So it will make changes in the output so that the V plus and V minus should be at the same voltage. So basically op amp operates as a differential amplifier, where it will amplify the difference between V plus and V minus. So suppose V plus is at 1 volt and 2 volt, and V minus is at 1 volt, then the difference is 1 volt, so it will amplify this 1 volt. So if it is gain is 10, then the output will be 10 volt. Okay, so what we want is, due to the in normal conditions when no input is given, this should be at a 0 and this should be at a 0, and we want the output should be 0 because the difference is 0. But it will not happen because of the manufacturing process. There will be some voltage which is present between the V plus and V minus, so it will be normally from 1 to 10 millivolt. This is the offset voltage for any commercial, that is cheap op amp. So if you are using for some particular application, then it can be reduced by using the biasing pins which are present in the op amp ICs. So this is the normal case. So assume the differential offset voltage is 0.1 volt. So you just want to assume it will be not in terms of volt for any op amp. Okay, so when we apply 0.2 volt as the input, then if the gain is 10, then the output will be 10 into 0.2. So as the 0.1 volt is already present in between these two terminals, we are actually applying only zero point 0.1. So it is added with the previous zero point 0.1 offset voltage, and it become zero point 0.2. But actually we are giving zero point 0.1 from our source, and we are getting 10 into zero point 0.2. So we are these two terms are not matching here, because due to the zero point 0.1 offset voltage where we are giving zero point 0.1, and due to the offset voltage zero point 0.1 is getting added, and we are getting the zero point 0.2 in the output. So this error occurs due to the offset voltage. Okay, so offset voltage basically means the voltage which is present between the positive and negative terminals of the op amp without any external voltage being applied to it. So it is always present in between these two terminals due to the manufacturing process. So there will be a copper wire which is uh, printed on the PCB, so that's why it will be offering some voltage drop across it. So that's why input voltage offset will be produced. So this problem will occur there. So that's why we want zero input offset voltage. So okay, so moving on further, so next point is infinite output voltage. So what it means infinite output voltage is, so the basic function of a op amp is to amplify the signal. So if you give 1 volt, we expect 100 or 1000 volt as the output. So basically we want the large output for a small input. So that's for it is created, that is amplifying the input signal. Okay, so the output voltage of the op amp should be very high. So we are terming it as infinite. So for small input, that is for zero point 0.1 input, we expect 100 volt as the output. So the output voltage range should be very high. So it will be from 0 volt to infinite volt. So that means very high voltage we are expecting here. So that's why in ideal case we say that the output voltage range of the op amp should be infinite. That is, it should vary from 0 volt to the infinite, 0 to 100, 1000, 10,000, 1 million, 1 trillion, like that. So the ultimate aim is to get the high voltage for the low input voltage. Okay, so that's about infinite output voltage. Then coming to the next point, infinite bandwidth with zero phase shift and infinite slew rate. So you understand this infinite bandwidth with zero phase shift. So infinite bandwidth basically is same as the infinite output voltage. So the output voltage should be very high, and it should be variable. So it can be 0 volt to 10 volt. In this case 10 minus 0, that is 10 volt is the bandwidth. So if it is from 5 to 50 volt, then 50 minus 5, that will be 45 volt. So this is the bandwidth. So we expect very large bandwidth. So that means the range of the output voltage produced by the op amp should be high. And with the term zero phase shift indicates, so if you are applying a sine wave here, then we expect a sine wave. So we don't want any phase shift. So if you are applying a sine wave with 180 degree like this, and we get a phase shift of 180 degree in the output, so this should not happen. So zero phase shift means there should be no changes in the phase of the output as compared to the input. If you are applying input like this, we will be expecting the output with the same phase, but the amplitude can change. Okay, and this is the important factor here. What is mean by slew rate? Okay, so slew rate is something like the the ability of the output to change in a unit time. Okay, so suppose this is the input, so it is changing like this. Okay, so it is passing through the op amp here and it is coming out. Okay, so this is the input in here and out. So the input is changing very fast here, so it is changing like this. Okay, so the op amp should be able to change the output according to it. Okay, so the something should not happen like the input is something like this and output will decay due to the op amp properties. So slew rate means ability of the op amp to change the output corresponding to the input in a given period of time. So it is something not like that input changes and then after a few seconds the output will change. So as soon as input changes, the output should be changed immediately without delay, because we will observe a error when the op amp gives a delay here. So in some cases what will happen, we are giving a square wave to the input, a square wave to the input, then we'll be getting the output somewhat like this. So it will be decaying and it will become like a sine wave. Okay, so the decay will be happening here. So this decaying of the input signal basically happens due to the slew rate, that is lower slew rate. So slew rate means ability of the output to change according to the input. Okay, so in some cases we will be giving sine wave like this, then we will be getting a triangular wave due to the slew rate properties of an op amp. So that should not happen with these op amps. Okay, so it should change the output as soon as the input changes. So that's why we should have a infinite slew rate here. So the next point is zero output impedance, that is R out. So we want output voltage as much as high as possible. So we want zero resistance at the output. So at that time only the output voltage can change rapidly or it can increase instantaneously. So that's why we want output resistance to be zero here. And the next point is zero noise. Of course, we in any electronic circuit we don't want any noise. Okay, so whatever will be the input, so we want the output corresponding to that input only, so we don't want any noise component, so it will disturb the output. Okay, so that is easy. And the second last point is infinite power supply rejection ratio. So I forgot one thing here. So slew rate, for slew rate the formula is slew rate is equal to 2 pi into Fe. So where F is the frequency of the input signal and V is the peak to peak voltage of the input signal. Okay, so this is the formula for slew rate. So where if we increase the frequency, then slew rate can increase, and if you increase the peak to peak voltage, then also the slew rate can be increased here. Okay, and coming to the last point, infinite power supply rejection ratio, here the formula is 10 log 10 of. So infinite power supply rejection ratio is what? So you are giving a power supply here, so let us say you are providing 3 volt. Okay, so you are providing a power supply of 3 volt, and we don't want to change the output. So you are giving, let us say 1 volt here, and the gain of the op amp is 10 volt, we are getting a 10 volt here. So if the power supply of the op amp changes to 5 volt also, then it should not affect the output voltage. So that is the ability of the op amp to resist against the changes in the input supply of a op amp. So that is power supply rejection ratio. So it should be resistant to the changes in the power supply. So if the power supply changes also, then it should not affect the output of a op amp. So that is power supply rejection ratio. So it should be as much as high as possible, because we don't want to change the output according to the power supply. We should change the output according to the input of a op amp, not due to the power supply. So it can vary in some cases. If it is 3 volt, then it can become 5 volt or 10 volt, but due to that the output should not be affected. So that is power supply rejection ratio, that is protection against the power supply changes in the input of a op amp. So the formula for power supply rejection ratio is here 10 log 10 of delta V square, that is supply, and AV square divided by delta V out square. So it will be in terms of dB normally. Okay, so here delta V square is the changes in the power supply. So if it is 3 volt and then it become 5 volt, means 5 volt minus 3 volt, so that will be the change. Delta means differential change, that is according to the time it will change. If for 1 hour it will be 3 volt, for second hour it will become 5 volt, then the differential change will be the 2 volt. So that's why we take delta here. And AV is the voltage gain here, so that is the output voltage by input voltage, and this is the output voltage, so that is delta V out square. So according to the input changes, the output will also going to be change, so that we will be taking the difference. So basically it is a difference formula. So difference in the input of a op amp to the difference in the output of the op amp, and this is the gain of the voltage, so it is multiplied with the voltage gain as well. So these are the characteristics of op amp. So I hope you like this video, and if you are not subscribed to the channel, please guys kill that subscribe button and hit the like button if you found the content useful. So thank you, thanks for watching, see you in the next video.